Hey guys, welcome back to the channel. Today's video is a continuation of our previous video on LeetCode 191, number of 1 bits. We solved it different ways using 2 different methods in the past, and they worked well. But today I just want to show you guys one more method. I'm not saying this method is better, I'm just saying it's different, just to kind of give you guys a different scope of how coding works. There's different ways. So first I want to show you something. I want to print the binary representation of n. Okay, we're given a number n. In this case, is a bunch of zeros, then 1 0 1 1. Let's see what that does. Again, this is going to give us wrong answer, but we don't care about the answer because right now we just care about what it prints out. So it prints 0b, then prints out the rest of the digits. Okay, just watch the input, prints out 0b, then the rest of the non-zero digits. Right, okay. So that's what the binary representation is. Okay, so now let's see, we want to get rid of the 0b in front of it, so we just have the real number, okay, minus the leading zeros. Okay, obviously we're going to start print from the second digits to the end. Okay, that's because it's 0 base. Strings has 0 base, kind of like lists. So that's 0, index 0, that's index 1, that's index 2. So we want to print from index 2 to the end. So let's see what that looks like. Again, it's going to give us wrong answer because we haven't yet solved the problem, but I just want to visualize some things for you guys to make it straightforward. Okay, so we've successfully taken out the first 2 elements in this number. Okay, so next I want to show you guys, I want to print something again, and here's the trick of the counter. It's called counter. It's a method provided by a package called collections. Okay, Python has this by default. It doesn't have it, you have to import it, but I believe LeetCode has it imported for you by default, so that's why we don't have to explicitly say imports counter from collections or something like that. So we have counter available for us, and I'll kind of show you what counter does. So just watch carefully, especially this counter. I'm sorry. I kind of see what it does. Okay, we're going to compare it to the other prints. Okay, so now I'm printing this element. Okay, so it's gonna counter. What it does is it gives us a dictionary, okay, of each element and the number of times it occurs. Okay, in this case, okay, 1 occurs 3 times, 0 occurs once. Okay, just keep track of that. So now we have how many 1s there are in this string. We also have how many zeros there are, but we care about 1 for this problem, right? Okay, so now by now I think everything should be coming together for you guys. I should be able to see what we're trying to do. Okay, so to be honest, we don't need these two. We can just print counter of n directly, right? Or obviously not of n. We're gonna have to, it's probably gonna give us an error, but I'm just trying this out here. It gives us an error, so we can just print by counter of binary of n, of the bin of n. Okay, so we don't need to take from the second index to the end. We can just leave it like this, and I think this should kind of give us what we want. Let's see it first. Okay, cool. So 1 3 times, 0 twice, b once. Okay, we don't care about 0, we don't care about b, we just want 1. So simply all we can do is we can get rid of everything else and simply just return this of 1. Okay, of 1. But before we do that, let's see what that does. Okay, we want to print just the key of 1. Okay, the key of 1 is 3 exactly, which gives us the number of 3s in here. So at this point we just get rid of everything else and just go ahead and just say return that. If I can spell return, I don't know what the hell that is. So return, and to be honest, you can leave the parentheses if you want, it's fine, but I'll just take them out just cause, you know. So now this should be a right answer. Let's go ahead and try submitting it. Okay, let's try running it first and just make sure. Okay, bam, accepted. Let's try submitting it and see what happens. Bam, 62% in terms of time, in terms of space, 65%. So let's compare it to our previous one. So it's slightly better. Timing is actually exactly the same, but in terms of space, it is slightly better. So that's it for this video, guys. I hope this was helpful. I hope this was simpler actually, and I'll see you guys in the next one.